Welcome, everyone, and thank you for standing by. I would like to advise you that today's call is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Tiffany Fairley. Thank you so much. You may begin.
Thank you. Good afternoon. I'm Tiffany Fairley with NASA's Office of Communications. NASA's third wet dress rehearsal attempt with a modified test procedure concluded yesterday, April 14th. The test focused on using the ground systems at Kennedy to load propellant into the Space Launch System's rocket core stage tanks with minimal propellant operations on the upper stage. The rocket remains in a safe configuration as teams assess next steps. Here to provide opening remarks and provide an update on the path forward for the Artemis 1 wet dress rehearsal are Mike Serafin, Artemis 1 Mission Manager, NASA Headquarters, Charlie Blackwell-Thompson, Exploration Ground Systems, Artemis Launch Director, NASA's Kennedy Space Center. And we'll also have questions available for Greg Horvath, Exploration Ground Systems Chief Engineer, NASA's Kennedy Space Center. And we'll start with remarks from Mike.
Yeah, good afternoon. We appreciate everybody's time to continue to follow the Artemis mission as we get ready for flight. Since the last time we spoke, the team has done a tremendous job of rolling in the lessons learned and the technical information that we obtained from our attempt number 1 on April the 3rd and attempt number 2 on April the 4th. Prior to this third attempt that we had yesterday for the wet dress rehearsal, the mission management team met a day prior on Wednesday the 13th, and the focus of that discussion was primarily to resync the team headed into yesterday's test. Key topics of discussion included, closure of the actions and kind of updates on the procedural aspects of the wet dress rehearsal and what equipment inspections had been performed following the 2 prior attempts. Specific to the pad environmental control system and the fan outages that we had causing the scrub on attempt number 1, some updates to the cryogenic loading operations that we learned through attempt number 2, and then some procedural aspects to preclude another liquid hydrogen vent valve issue that caused us to scrub on attempt number 2 as well. Since that time, as you're aware, we had the issue with the interim cryopropulsion stage, or the upper stage's gaseous helium vent valve, check valve, and we modified the wet dress rehearsal procedure for that. So there were a number of changes that we talked about headed into the attempt number 3. And at the end of that meeting, the day prior to the test, we polled all the elements and all parties polled go. On the day of the test, we met with our launch director to talk about status and readiness for the attempt yesterday, and we had a very clean meeting. It took only about 25 minutes, and we had great support there from the range. The weather was great for the test, and the launch team and all of our support sites in Huntsville and Houston said they were ready to go. The rocket was ready, the spacecraft was ready, so we proceeded into the test. And during the wet dress attempt number 3, we encountered some issues with the cryogenic loading operations. Our launch director, Charlie, will walk you through that, both on the hydrogen and liquid oxygen side. And as the team worked their way through the cryogenic loading operations and got further into the operation than we did on our prior attempt, and gain new technical knowledge and new technical information to prepare us for flight, we encountered a liquid hydrogen leak, or an LH2 leak, on the tail service mast unit. The tail service mast unit on the LH2 side sits on the deck, the zero deck of the mobile launcher, and it's about 30 feet tall, and there's an umbilical plate that is on the ground side that provides the cryogenic fuel, in this case the hydrogen, from the cryosphere at the perimeter of the pad and up through the mobile launcher system. That umbilical plate provides the interface with the Space Launch System rocket to fuel the core stage. And it was on the ground side of that umbilical plate that we saw the hydrogen leak. And after troubleshooting it, the team decided to knock it off for the day, because when you have hydrogen leaks, and you have ambient oxygen out there, you only need an ignition source to close the fire triangle. So it was a flammability risk, and we knocked the test off as a result of that. Following the wet dress attempt yesterday, the mission management team met again at 6:30. It was a fairly long day for the MMT. We took about 45 minutes to roll up all the information we obtained through the test, and we talked about the art of the possible moving forward. And we've got a couple of options in front of us. We're not ready to say exactly what the option is. It's been less than 24 hours since then, and folks had a pretty long day yesterday. I'm sure our launch director probably had the longest day because she got up before us to prep for the tanking meeting, and then worked all the way through the day and was there with us at the end of the day when we had our post-scrub MMT meeting. But we've got a couple of options in front of us. We are preserving the option to reattempt a wet dress as early as next week. Thursday the 21st is kind of the earliest time that the team is comfortable with doing that. We are aware that our commercial crew partners and friends that are going to be over on Launch Complex 39A are setting up for a launch attempt on the 23rd to launch Crew 4. Obviously, there's some coordination that we will continue to do with our range counterparts and our commercial crew and commercial LEO friends, and we're going to stay in close contact with them as we get smarter on our path forward. So that's pretty much my opening comments and our adventures in cryo loading and our readiness. But as was said earlier, the mega moon rocket is fine. All the issues that we're encountering, I would say, again, are procedural and lessons learned, with the exception of this ground umbilical plate that we've got to go figure out where the leak is, and we've got a couple of options that we're looking at there. So with that, those are my opening comments.
All right. Well, thanks, Mike. Let's see. It's Charlie Blackwell-Thompson here, Artemis Launch Director. Hello, everyone. Thank you for your time today. I want to start off by saying that I'm really proud of the work that our team has accomplished and that we continue to do as we get through wet dress rehearsal. Yesterday and throughout the course of the countdown, which started on Tuesday afternoon, we continue to listen to the hardware. We continue to learn as part of this process, and we will continue to do that as we work through the remaining ops of wet dress. To start off, our call to station started right on time at 5 p.m. on April 12th, on Tuesday, and the teams worked through the procedures in configuring the flight hardware and getting us ready for tanking. And as Mike described, we got into our tanking brief yesterday morning. I had to think about that for a second. Got into our tanking brief yesterday morning, and really we were all systems go. We did experience an outage of gaseous nitrogen from the off-site supplier just as we were getting ready to begin our tanking operations, and so that set us back a little bit in our propellant loading timeline. Once we reestablished the supply of the GN2, our team started the operations to load liquid oxygen into the rocket's core stage. While loading liquid oxygen, or LOX, as we like to call it, the teams we encountered a similar issue to what we had during Run 2, where we had a temperature at the inlet that was showing a little warmer than we expected, and so our teams took a moment to go off and reassess the situation, and came up with an alteration to our plan and put that into work, and we got right into our loading operations on the LO2 side of things. So shortly after we got into that operation, we began to look at the hydrogen side of the interface. We had been very anxious to load hydrogen. As folks know, the hydrogen molecularly is very small, and at cryogenic temperatures, sometimes in the beginning stages of loading is when you will see a leak. We got through our slow fill operations. Everything was nominal, had no issues. And when we transitioned to fast fill, which you will see an increase in pressure as part of that loading operations, we did detect a leak on the tail service mast on something that we call the purge can, or the purge canister. It's actually on the back of the ground side plate, and we can talk about that a little bit more in the questions. But we did see a leak there. We had a couple of different contingency scenarios or contingency plans that we can put into place or utilize, and we did that, but it did not resolve the leak. So we went ahead and safed that operation, got into our stop flow and into a revert, and decided that we would move on to the upper stage chill down operations as we had described in our previous press conference. We did that. Everything worked pretty much as expected. We continued the countdown down to the T-minus 10-minute hold, and as part of that T-minus 10-minute hold, we were able to not only accomplish the core stage LO2 load to just about halfway, about 49%. We did get the core stage LH2 flow fill as described, and then the upper stage chill down. We also did our flight safety system testing. Our range safety system testing was completed. We did first motion checks. We had our booster DFI checkout as well. We did our commanding with the Johnson Space Center. Our Dolly operations were all worked. We did our tanking outer mold line scans. Those were completed. We did some of our guidance and navigation checkout, the Orion comm system checkout, and we were also able to demonstrate a number of our contingency procedures. So while we did not get all the way through the planned activities, we certainly accomplished quite a bit. So after working through that, and as I said, getting down to the T-minus 10-minute hold, we decided to end the day as Mike described, knowing that we would not be getting into the terminal portion of count. Again, the team did an excellent job in accomplishing the objectives as briefed, and so we really saw very good performance across the flight systems, and again on those things that on those activities that we accomplished, we didn't have any significant issues besides the leak that we're going to talk about a little bit more in detail in just a second. So after calling it a day, we got into our drain operations and got into our purges overnight. This morning we began working up our troubleshooting plans for how to go assess the situation, and then also getting the pad opened up and starting to get back configured. So this is on the LH2. The LH2, there's a, and I'm sorry you guys can't see my hand motions here, but you've got the LH2, you've got a flight side plate and a ground side plate, and it's really what I call the back side of that plate. There's a purge canister there. The good news is that there's only a few things in that purge enclosure, and there's a couple of discrete penetrations there that we think could be the culprit or could be the cause of the leak. And so we'll go, what we're setting up to do now is we're getting access. We have access stands in the VAB. We currently have those, they're at the pad. We had them taken from the VAB to the pad this morning. And once we get the mobile launcher zero deck configured, we'll lift those up, get them into place, and we'll begin assessing those areas of the TSMU and taking a look at what we think the issue might be there. So the team's developing a troubleshooting plan. They got together this morning to look at these particular areas that we think could be the issue, how we get access to them, how we troubleshoot them, and then what the forward plan is. So I think that's where we are right now. And then while we're doing that, we'll also be replenishing commodities, preparing our timelines and our procedures to get ready for the next opportunity.
Thank you so much, Charlie. We'll now begin with the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. You can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. Your phones are now on mute, and the operator will open your mic when we're ready and close your mic after you've asked your question. Again, we ask you please stick to one question. Shortly after we conclude, you can listen to a replay of this teleconference online. And we'll go ahead and begin with Marcia Dunn with Associated Press.
Yes, hi, for Mike. I'm just wondering if one of the options under consideration is, given that there is a launch coming up on the pad right nearby, just going right back to the VAB, replacing the valve in the upper stage, taking care of any other issues, and then going back to the pad. Is that under consideration at all at this point? And if you do a complete top to bottom wet dress rehearsal, how much extra time in processing would that be? Thanks.
Yeah, Marsha, I'll take the first part of that question. Charlie probably has a better sense of the timeline, but in terms of what the troubleshooting plan is, we're kind of breaking it down into a series of kind of low-hanging fruit options, things that are readily accessible. We hope that, there's something that is fairly straightforward and needs to be adjusted or is easily resolved, and we can do that at the pad and do it in fairly short order. And then there are a couple of more invasive options, and we've got to weigh those against a whole host of considerations that include, putting additional just wind stress on the vehicle. The longer we stay at the pad, the more we stress the vehicle. It's 32 stories tall. Every time the wind blows against it, it creates a bending moment, and over time that adds up. We got to weigh that against environmental exposure out in the field, but then also the rollback to the vehicle assembly building. To reattempt a wet dress rehearsal actually puts stress on the vehicle as well. So we've got a series of actions that we've asked the team to go off and provide data back based on the core stages experience, going all the way back to the Stennis Space Center and the Green Run hot fire test and the stresses that we saw it go under not only there in the test stand, but also during transportation and some of the activities here at the Cape. We've got a whole host of other constraints that we're looking at as it pertains to interfaces with the spacecraft, and we're going to weigh all those, and we've got kind of what I call a bucket of considerations that we need to all bring to the table. And we talked about what those were last night in the post-scrub mission management team meeting. And I think once we get a better understanding of what all the considerations are, I'll be able to better answer your question. And Charlie, I don't know if you have any feedback on the timeline as far as what it might look like.
I really think it's hard to say specifically because I think it depends on the scenario. Certainly there are options within the trade space. I mean, if we looked at our planned schedule from a rollout to wet dress, I mean that's somewhere in the 7 to 10 day range. If you look at what we just did as we rolled out for wet dress, but there are different options that could be in play there. I mean, you could certainly look at your schedule risk for launch countdown, and you could make a decision of whether or not you wanted to do a tanking prior to a launch countdown. I mean, we have a certain number of days that we can be at the pad before we begin to bump up against our range requirements. And so you could make a strategic decision to go utilize one of those for a wet dress or a tanking and do that, and then some days later decide to go launch. So I think it really depends on the scenario from, your rollback to your first, if you were doing a tanking test, a wet dress, or a launch.
Thank you. Next we'll have Bill Harwood with CBS News.
Thank you very much. This is for either one of you, I guess, but can you develop rationale to fly without ever fueling the ICPS in a test? And I'm asking that because, most of the problems you guys have been on the ground side versus the rocket side, but there have been issues, all the way through. I'm just wondering, could you get to a point where you could actually launch the rocket without ever fueling the ICPS? That's my question.
Yeah, Bill, fundamentally it comes down to risk acceptance and what we consider to be an acceptable level of risk. So I do believe that there is a path forward provided that we understand what the risk is. It would include a whole host of considerations, including the Delta IV Heavy flight history and the Delta Cryo second stage, and the history of this particular flight element, and what data we've obtained through the testing to date, that some of which is at the pad, some of it is in the vehicle assembly building, and some of it was done before the interim propulsion stage ever arrived at the Kennedy Space Center. And we would have to weigh all that and understand the risk, and either agree to accept that risk or decide what the Delta work would be to get to an acceptable level of risk. We are not done with our flight test program or our ground test program yet, and we're not ready to make that determination just yet.
The only thing I would add there, Mike, is that, we're not talking about a flight safety risk. When we talk about that, we're talking about we do have launch commit criteria that if we were to make that decision, and I know that that's still ahead, there are launch commit criteria that protect you in the event that you were to have an issue during launch where you had an issue with loading. I mean, that would scrub your launch, but that would be the scenario that we would be talking about there, is it's really a launch countdown scrub risk versus any kind of flight safety risk.
That's a great point, Charlie, that there are also controls outside of the testing in place, and the launch commit criteria is probably the single best example of that.
Thank you. Next, we'll have Irene Klopp with Aviation Week.
Thanks. Good afternoon. Probably this is for Charlie. The hydrogen leak signature, was it gradual, or was there a sudden increase in the concentration of hydrogen in the tail mast? And could you describe a little bit about what data you can get without doing a tanking that will let the team know that the leak has been found? Thanks.
Yep, I can absolutely speak to that. And one thing I probably should have clarified when I was making my opening remarks is that in the cavity itself, between the flight plate and the ground plate, we did not see a leak. We actually saw this really on the back side of the plate. And so that's really good news for us, because the access is much different and much easier. And what we saw is that as soon as we went into fast fill, we saw the leak go up pretty quickly. It wasn't a gradual leak. We saw it spike up. And I know you can't see my hands here, Irene, but what happens is around the backside of that plate, there's like a purge shroud, and it's a fairly small enclosure. And so any amount of leakage in that enclosure, when you've got a sample line in there that's pulling that and looking at that concentration, I mean, it's a small volume, and so any amount of leak is going to send your concentration up pretty quickly, and that's what we saw. As soon as the teams went into stop flow, we saw that leak just as quickly as it went up. We saw it come right back down, and so that was what we saw yesterday as during the test operations. And in terms of the path forward, and I'm going to pull Greg in here too, because he's our chief engineer for the ground systems. In terms of the path forward and what we can do, there's a number of things that we believe that once we get access, we can go take a look at. As I described, there's a number of discrete penetrations into this area, and so the first thing is you want to go check those. And do you have anything that's loose or obvious? There's also some ambient leak checks that we can go do on the system, and then there's some other leak checks that we can do. This area is typically purged with helium. We could change the purge in there and run some helium through some of these other areas, and use some of our gas detection equipment to go see where we're seeing leaks from. So we have a couple of tools that we can go that'll help us evaluate this particular area and these particular penetrations and figure out which one's really causing us the issue. Greg, anything to add on that?
You covered it mostly, Charlie, yes. So on the back side of that ground plate, we'll call it, there is a purge can. It's a two-piece metal can that we bolt together within that can, we have several penetrations into the fill line and the bleed line. We don't think the bleed line's an issue because we weren't flowing through it. There was no pressure on it. And the signature of the leak happened when we transitioned to fast fill. We rapidly increased pressure in that line. The penetrations into the line, there's 3 of those on the fill line. And then we have a flange connection, which has 2 gaskets with a debris plate between them. That's a bolted flange on the 8-inch line. That's another potential leak point as well. So like Charlie said, we do have access to that area at the pad with the access stands. Once we take that purge can off, we'll have ability to do a leak check. Now, ambient leak check is not the same as a cryogenic leak check at minus 423. So, a lot of times when we do leak checks, we don't see a leak at ambient, and then you get to cryogenic temperatures, and it does leak. So we're hoping to see something obvious with one of those penetrations into the line, and then we'll go from there as we get the data.
Up next, we'll have Eric Berger with Ars Technica.
Hi, thank you very much for doing this. I've got a couple questions. First for Mike, I think, is there a scenario in which you would actually launch the mission without completing a core stage wet dress test? I mean, you talked a lot about sort of the potential wear and tear on the vehicle and systems being out at the pad. I'm just wondering if you'd get to a point where you would go without doing a wet dress test through terminal count. And then for Charlie, I think, can you tell me how long it's going to take to launch? How long you have to launch or roll back to VAB once the flight termination system is armed? I think I've heard something like 3 weeks, but I'd love a clarification. Thank you.
Yeah, Eric. So on the core stage, one of the, I would say, the primary objective of the wet dress rehearsal is to demonstrate the ability of the ground systems to perform these cryogenic operations with the core stage, and excuse me, our ability to demonstrate both of these commodities under flight-like conditions or ground test conditions is what we're really after here. And we have a very large vehicle, and we're flowing a lot of commodity, and we've got some really complex physics going on. I would argue they're PhD level physics. In order to complete the operation, we have to characterize those appropriately, and it's something that we need to go off and get enough data to show that we can complete these operations under the conditions that we will need on day of launch. That said, I mean, it's possible that we will get enough data at some point that we'll be able to demonstrate or have enough confidence in this, and we'll just have to see, what residual risk there is there. I wouldn't say that that's something that is really in the forefront of our mind right now, but it's something that that we could consider moving forward. I just don't see that right now as our primary objective. Our primary objective is really getting past this leak and getting into a wet dress. And Charlie, I don't know if you want to handle the time to launch question.
Yeah, so we do have, I believe what you're referring to is we do have a requirement for the range for the flight safety system, and we do have a timeline associated with that, and that's 20 days.
Next, we'll have Andrea Leinfelder with Houston Chronicle.
Hi. I would like to put this wet dress rehearsal into a bit of perspective. I'm not sure if this is a question for either of you, but I'm curious how it compares with the wet dress rehearsals for the Space Shuttle and the Saturn V rocket. Like, if you can describe how long those tests took and what type of issues were discovered, just so we can put this a little bit in perspective for readers. Thank you.
So let's see, I'll take a shot at this one, Mike and Greg. If you guys have any additional info, feel free to jump in here. So I have the honor of working with one of the engineers. He's actually on our cryopropulsion team that was around for STS-1. And so we were just talking about this week. How many tankings did it take before we got ready for launch? And I think the number was somewhere in the 5 to 6 prior to launch for STS-1. And so if you look at that in the context of kind of where we are, again, shuttle was a single stage vehicle. We're trying to load 2 stages, so you gotta get the core stage and upper stage. There are some complexities with that load compared to shuttle. And so I would say, putting it in context, I would say we're within family of our experience in the past for first-time ops is how I would characterize it. But Greg or Mike, if you want to offer.
Yeah, Andrea, I would say we occasionally get to talk with some graybeards that are around from shuttle or the Apollo Saturn time frame, and they will tell us that, you know, these systems are incredibly hard to characterize. You've got complex physics going on. You've got fluid dynamics. You've got thermodynamics. You've got flammability hazards. You've got cryogenic temperatures and structural stresses you're putting on it, not only from the weight of the propellant, but also the structural stresses come in because you're literally causing these very large cylinders to change shape because you're chilling them down to, you know, minus 280-ish degrees on one side and minus 450 on the other. So, you know, when you take into account all these stresses and strains and fluid flow rates, and you want to avoid having things like a geyser, which is a two-phase flow moment, and the thermodynamics that you're trying to stay within or avoid, and all the hazard controls and all of the other constraints and considerations in play, I would say we're in family. We've got much more advanced engineering models and techniques, and the ability to build precise pressure vessels using state-of-the-art welding techniques and that kind of stuff, so that the flight hardware is done quite well. It's really adjusting the two together that's been a problem for us, and I would say that, you know, again, history has shown it's been a challenge for pretty much anybody that's done anything of this magnitude.
Next, we'll have Jeff Faust with Space News.
Good afternoon. A question for Mike Serafin. You mentioned in your opening remarks you were looking at a couple of options, one of which was to try the wet dress again as soon as the 21st. Apologies if I missed it earlier, but what other specific options are you looking at right now in addition to trying the wet dress later next week? Thanks.
Yeah, so, you know, the options are, again, it's really what are the low-hanging fruit options, things that are relatively straightforward, easy, obvious, that need to just be adjusted on this purge canister, the penetrations that maybe there's an obvious leak source, and to basically rectify that. There are some more invasive options that require getting further into the hardware and potentially having to get into some extended troubleshooting, and then where is the most appropriate location to conduct that. I would say that's kind of the spectrum of what we're looking at, but there are other constraints and considerations that we're looking at that have to do with the pad environment, or if we were to choose to not do this work out at the pad, what we would be giving up or gaining in that case. So there's again a number of considerations there. I don't want to get in front of those decisions. We're not ready to make that decision. We haven't fully outlined all the options right now. The one that we're pursuing, I would say, with great vigor, is the low-hanging fruit option, and we'll let the team kind of come up with some other options here. Again, it's been less than 24 hours since we ran into this problem.
Next, we'll have Ramin Skiba with Wired Magazine.
Hi, thank you. This is, I guess, a question for both of you. I just wanted to follow up on an earlier question. would you say that, considering the complex physics involved and how these are in many ways new pieces of hardware, and there's a lot at stake with this rocket, are you still very confident about continuing or finishing the wet dress rehearsal test on the launch pad and hopefully launching in the next few months? Like how confident do you feel about the process at this point?
Yeah, Ramin, I would say the Mega Moon rocket is fine. The vehicle has performed really well. The only thing we're seeing on the flight side is this check valve on the upper stage. That is a relatively straightforward thing to go off and resolve. The other things that we've learned have been largely procedural or slight adjustments in the operation or the limit sets or some of the software triggers. Those are things that are relatively straightforward to go off and do. You just need a little bit of time to work through them and confirm that you're staying within the system constraints. And then this hydrogen leak, and that's on the ground side. So, I'm confident we're going to get there. If you want an exact date, I can't give that to you right now. It's really just we will be ready when we get through the test program, and we are. I can promise you, we are working hard to get through it. We are putting in some long hours to do it, and we will let you know when we know when we're going to set up for a launch attempt. I don't know, Charlie, if you have any thoughts on that.
Yeah, I certainly have some thoughts on it. I mean, there is no doubt in my mind that we will finish this test campaign and that we will listen to the hardware and the data will lead us to the next steps, and we will take the appropriate steps and we will launch this vehicle. As Mike said, I don't know exactly what that date is, but there's no doubt in my mind that we'll finish the test campaign and we will be ready to go fly.
Thanks so much, and we'll have time for a final question, and that'll be Micah Maidenberg with Wall Street Journal.
Hi there. I think this is a message for Charlie. Could you remind us which contractor was responsible for the umbilical where the leak appeared, and what sorts of communication, if any, you've had with that company about this issue? Thanks.
And so let's see, it is our ground hardware on the ground side of the interface where we saw this particular leak. In terms of the manufacturer of that, I'll have to get back with you on that, unless Greg, you have information. Okay. Yeah, we'll have to get that for you. But the hardware belongs to the ground systems.
Thank you all for joining us today. You can listen to a replay of this teleconference online by visiting the Media Resources tab at www.nasa.gov/Artemis-1 later this afternoon. To follow along with updates for the wet dress rehearsal test, please go to the Artemis blog at blogs.nasa.gov/Artemis and join us on the NASA Exploration Ground Systems Twitter account. You can also watch a live stream of the rocket on the pad at the KSC Newsroom YouTube channel. For those who are planning to tie in to the Crew 4 media teleconference, that has been moved up to 4:15 Eastern Time. Thanks again, and that will conclude our call.